Hello everyone, this is Hating Tian. In this video, let's learn 4.2 logarithmic function. I cannot move this button away. All right. Okay. What is logarithmic function? It is the inverse function to the exponential function. The exponential function we have learned f of x equals b to the x. If the b is greater than 1, I'm having an increasing function like this. And its inverse function is symmetric along the y equals x. This is y equals x. We have learned this before in chapter, I think that's chapter 2. The inverse function is symmetric along y equals x. So its inverse function should be like this. So we say this g of x. What does the g of x look like? Is constant. X is variable, and make sure that x is greater than 0. So everything here is positive. We do not solve the negative, or there's no negative for the logarithm function here. All right. Let's see the logarithmic form and exponential form. The logarithm form, if we have the x equals log base b, x, make sure that the b is the base, just like the exponential form, the b is the base. Then we need to swap the xy, because we know that if they are inverses to each other, we swap the x and y. So the b is a base, put the base here and swap the x and y, put the y on the power part, and then put the x on the another side of the equation. All right, let's convert the logarithm form to the exponential form and solving for the x. First, if we have the logarithmic, we can convert to the exponential form. Keep the base 2. To the then another side, isolate the x. What is 2 to the 4th? 16 equals. And then example 2, 3 equals log base b 64. Rewrite it. B is the base, 3 is the power, equals 64. B to the cubed equals 64. 64, I know that's the 4 cubed. So we have b cubed equals 4 cubed. Why I'm converting the 64 to the 4 cubed? Because if they have the same power, the base must be the same. So b equals 4. All right, let's see number 3. Convert the exponential form to the logarithmic form. First, what is the base? Base is here. If we have the base here, we have the log. Base is 2. So 1 over 16 equals -4. Next one, evaluate each expression without a calculator. They are all logarithm expression. We can assume that they are equal to a variable. You can put x, you can put y. I put y, so convert it to the exponential form. 4 is the base. Power equals 16. Then convert the 16 to the base 4. Yes, 16 equals 4 squared. So 4 to the y's power equals 4 squared. Y equals 2. Next one, we assume that one equals y. So 2 to the y's power equals 64. Can you convert 64 to 2 to the base 2 and the power something? We can try. So we know that 2, so 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6 is 64. Okay, so 2 to the y's power equals 2 to the 6. They have the same base, y equals 6. That means all of this is expression equals 6. Let's see, next one, 25. 25 log base 5, 1/6. Assume this one equals y. I'm back. 5 to the y's power equals 1/5. Can you convert 1/5 to the base 5 and then raise it to some power? Yes, we can. If we see 1 over something, that means the power is negative. So 5 to the -1. They have the same base 5. Y equals -1. It's different color. Next one, assume this one equals y, solving for the y. Rewrite it. 2 to the y's power equals 1/8. If we see 1 over something, I can bring it to the top, raise it to the -1, but they have no same base. Can you convert the 8 to the base 2? 2 to the y's power equals, make a big parentheses for the 8. 8 equals 2 cubed. I know that we multiply these two powers. So 2 to the -3. Y equals -3. All right, let's see next example. Log base 7 square root of 7 equals y. 7 to the y's power equals square root of y. Square root of 7. And then can you convert the square root of 7 to the base y? Base 7. Yes, if we see the square root, that means we have the base 7. The root means the power part is a fraction. And then what is the root? That's 2, square root of 7. So we put the square root, which is the 2, to the bottom part of the fraction. Now they have the same base, 7, y equals 1/2. Next one, so assume this one equals y, solving for the y later. Rewrite it into the exponential form. 2 to the y's power equals 1 over square root of 2. If we have 1 over something, that means raise it to the negative power. Square root of 2 to the -1. And 2 to the y's power. And can you convert this one? Has the base 2, same base. I can solve for the y. Yes, we can, because in the parentheses, we have square root of 2. That's the 2 to a fraction power. The bottom is 2 because we have square root to the -1. 2 to the y's power equals 2 to the, do the multiplication, -1/2. Y equals -1/2. So the expression is -1/2. All right, let's see next example. Assume this one equals y. So 64 to the y's power equals 8. How to convert the both sides have the same base? Maybe I will start from the 64 because this is big. I can convert it to 8 squared. Then to the y's power is 8. Because I know 64 equals 8 squared. Then I will create the same base, 8. Let's see, multiply 2 and the y. So 8 to the y, 2y equals 8. What is the power of 8? That is 1. So 2y equals 1 divided by 2 both sides. You have y equals 1/2. And this question, we also have another method. We say way 2. Why? So if we have the expression 64y equals 8, you can also convert the 8 to the base 64. But I know most of you doesn't like this method. 8 equals square root of 64. Then I can convert the square root of 64 into 64 to the 1/2. They have the same base. Y equals 1/2. In my experience, most of you like this method because you make the small base 8. You're not making a big base 64. But you can choose either way and got the same solution. Let's see, next part, properties of logarithms. If we have, make it bigger, if we have log base a equals 1. So why did that happen? Because we can rewrite the logarithm form. A to the power 1 equals 8. Yes, it is. A raised to the first power, that is 8 again. So this is a property. Second, log base a 1 equals 0. Because if I rewrite it, base is a and raise it to the 0 power, we have 1. Yes, a to the 0 power is always 1. Next one, if we have the log of base a, here's a to the x power, that equals x. You can cross out this. So why that happened? Because if you rewrite it, a is the base, and put the x in the power part, equals a to the x. Yes, it is true. So this is a property. You can do this next time. Cross out all of these. You have x left. Next property, if we have a to the log base a x, that's the x. You can cross out the base a and the log base a. Then you have the x left. All right, let's use the properties to solve these these 4 examples. Okay, log of base 5. Is that 1? Because the base and 5, they are the same. They are all 5. So we have 1. If later we have log base 1000, here is 1000. We still got 1. Next one, that's 0 because this is a property. So if you forgot the property, for example, you can do this. In previous examples, we said you can assume this one equals y. So 4 to the y's power equals 1. 4 only to the 0 power, we got 1. So y equals 0. So that's 0. But I prefer you memorize this property. If here is 1, we always get 0. All right, let's see next example. What property I'm using? Base is 5, and here is 5. We cross out this, we have 7. And base is 8, and log base 8, we have 19. Clear? All right, let's see next part. Logarithmic functions with base 10 we call common logarithm function. So most of the time we just ignore the 10. If we have log base 10x, we just say log x without saying log base 10. We call this common logarithmic function. If the base is e, we call this form as natural logarithm function. And we have log base ex, but normally we will say this is log, alpha of x equals lnx. Ln key on calculator are defaulted to natural log base e. Why I'm talking about the common base and the natural log base? Because we can find these 2 buttons on our calculator. Next to the 7, button 7, and that is button and 7. You can use these 2 to do the computation. All right, let's come back to see the example. Number 81. Let's find what is the value of log 100. So we know that log without showing your base, that means the base is 10. Can you convert the 100 to the base 10? I know 100 is 10 squared. And the log base 10, 10 squared. And so we got 2. Okay, so log, even I don't have a 10 here, but I know that's common log, 10. So we have 7. And next one, 10 to the log 33. We can put a small 10 here, do cross out. We have 33 left. We're using the properties. Now we are found number 1. What is that? 0. Here, we always have the value is 1. And here, what is the base? For example, we have 10, we have 10, we have 100, 10, 1000. We always have 0. All right, let's see. Next example. ln e to the 6. Cross out the ln and e. So we have 6. Because I know that the ln e is log base e. E to the 6. Log base e, they canceled. We have 6 left. And next one. So what is ln? 1 over e to the 6. I really want to convert it to the ln e to some power. Then I do the cancellation. Can you convert it to the form of ln e to some power? Yes, we can, because we know that 1 over e to the 6, I can flip it to the top and raise it to the negative power. We have ln e to the negative 6. So ln and the e, they canceled. We have negative 6. All right, let's see number 93. Oh, no. Heck. Okay. 93. E and ln, they canceled. 125. ln e to the 9x. ln and e, they canceled. We have 9x. All right, let's see. Find each of the following using calculator round to 4 decimal places. All right, let's use our calculator. We're evaluating log 3. If we have log 3, we have no base there. That means the base is 10. That's common log. Let's use the calculator. Okay. Log 3. How to move this away? All right. No, come back. So log 3, close the parentheses. You see where I find the log next to the 7, and hit enter. We have 0.4771212. So we keep 4 decimal places. We keep 4771, and I will not get one more, because after the 1, after the 4th digit, we have 2. 2 is less than 5. So we just keep 0.4771. Next one, log 532. Let's put it in the calculator. Log 532. Close the parentheses. Hit enter. So keep 4 decimal places. 7. So after the decimal places is 7259. Ignore the 1 because 1 is less than. Okay. So do not put equal sign because it's not equal. We put 2.7259. Next one is here. So I will also put approximate sign. So let's put log log -2. So negative sign is next to the point. Are we going to have a solution? We mentioned that we must have positive solution, or sorry, positive value in the log or ln or any base of the logarithm function. So hit enter. No, because that's wrong. I shouldn't have a -2 here. I must have something greater than 0. -2 is negative. So I cannot have any solution for this. I will put no solution. And your calculator also cannot find any solution for this. All right, let's see next two examples, ln2. ln, you find the ln button here. Click ln, put the 2, close the parentheses, hit enter. Zero 0.6931, because after 1 is 4. 4 is less than 5. So we ignore the 4. How about next example? ln 809.3. Close the parentheses, hit enter. We are having 6.69617. Am I right? No. I only need to keep 4 decimal places. So the 4th decimal is 1. After the 1, we have 6. So 6 is greater than 5. 1 must be added by 1. So we have 6.6962. All right. We solved this part. Let's see. Use the common logarithms and natural logarithms and a calculator to evaluate to 4 decimal places. Now, if I have the different base, I have log base 4, for example, here. My calculator, come on. My calculator doesn't have the function log base 4. I only have the log base 10 or log ln, that's the log base e. So how about log base 4 to the 100? I can use change of the base formula. If we have the log base b, m, we can split the b and m. We can move the m to the top. Log base a to m, and the log divided by log base a, b. We separate the m and b, and then I create a log base a. I can choose any number for the a. I can choose 2, I can choose 5, I can also choose 10. That means I can separate the m and b, and I will choose an easier base. I can say, I will choose common log, the base 10, and log b here. Then my calculator will show me what is log m and what is the log b, and find the ratio of this. So for example, if I have log base 4, 100. Why I'm changing the iPad, because that iPad doesn't have a calculator. I really want to show everybody the TI-84, TI-83, the calculator, to show you how to do that. If we don't have, I don't need to use the calculator, I will switch it to my iPad, because my laptop always doesn't listen to me. Okay, all right, let's separate the third and the top, the log 100 basis, the bottom is 4. Then my calculator will show me this solution. Let's see. On the top, we have log 100. One more. And then divided by log 4. Close the parentheses. Hit enter. If I keep 4 decimal places, we have 3.321 9. After 9, we have 2. 2 is too small. Next one, you can pause the video and do it yourself. I need to separate the 17 and 0.5. I'm choosing ln. It doesn't matter you choose log or ln. The base, it doesn't matter. So ln 17 divided by ln 0.5. Let's use a calculator. We have ln 17 close the parentheses divided by ln 0.5 close the parentheses. Hit enter. We got a negative number. What is that negative? Negative 4.0874. After the 4, we have 6. 6 is greater than 5. So we add one unit to the 4. So we are having negative 4.0875. All right, let's move on to next part. Now I don't need to use calculator. Find the domain of the logarithm function. Here is a hint. Do you remember I mentioned at the beginning of the class, we said the logarithm function, the graph is, so if the base b is greater than 1, we're having increasing function like this. So look at here. This one we called vertical asymptotes. X equals 0, and the form of the function is log base b x. So the domain is from 0 to infinity because all the x value is up. So this graph is approaching x equals 0, but never touch it. So domain is from 0 to infinity. And remember that x never be a negative number. That means everything here in this part is positive. So I'm looking for the domain for the function x plus 4 is greater than 0 and never equal to 0. We must have positive. And minus 4 both sides. X is greater than negative 4. How to write it into the interval notation on the number line? We find negative 4 greater than negative 4. We're having the interval on this side from negative 4 to infinity. This is a domain. How about domain for next example? So everything here is positive. 2 minus x is greater than 0. Solve for the x. I can add x both sides. 2 is greater than x, or you say x is less than 2. On the number line, find the 2. X is less than because it's pointing to the small number. So x is on the left side. Domain is from negative infinity to 2. So these are the domain part. Graph of a logarithm function. We know that function looks like f of x equals log base bx. If the b is greater than 1, we are having increasing function, and vertical asymptotes is x equals 0. So this is that vertical asymptote. If the b is between 0 and 1, so we are having a decreasing function, and the vertical asymptotes is still x equals 0. And based on the function, logarithm function, we can do the transformation. So for example, number 78, if I'm looking for the graph of g of x equals 8 minus ln x, first I can put the mother function f of x equals ln x here. I must know that the graph of ln function. So is a function like this because ln the base is e. E is greater than greater than 1. I'm having an increasing function, and it always passes through the point 1, 0. Because if I input the 1 inside here, so ln1 is always y's value is 0. So how to transform this one? How to transform f of x to the g of x? We can rewrite the g of x. 8 minus f of x. Okay. First, the transformation is reflection because in front of f of x, we have negative sign. So first transformation is reflection along the x-axis. So all the y's value multiplied by -1. And then second, we have an 8 here. That means we add 8 on all of this part. So we are moving up to 8 units. Move up 8 units. That means all the y plus 8. And then how to graph this? So we can use this key point, at least the key point here. 1, 0. And then the g function key point. X didn't change, so put the 1 here. How about 0? 0 times -1 is 0. 0 times -1. And then plus 8. We're having 1, comma 8. So the new key point is 1, 8. 1, 8. Okay, so what does the graph look like? Is the graph like this? Because we're doing the reflection. So we can reflect this image first. For example, this represents the reflecting. And then move up 8 units. So this key point, move up 8 units. Here's 8. We're having the new function. I'm using this. So this is a new function graph. And later, if you have more transformed function, for example, I have h of x equals log, natural log, x plus 2. What is the transformation? Inside of the parentheses means the f of x plus 2. Because you plug in x plus 2 into the f of x, you will have this is ln. So for example, f of x equals log x. So we replace the x with the x plus 2. So we can find the relationship between h and f. That means we are moving to the left to unit all the x minus 2. Then we plot the key point and then find the new key point. We will know that we are transforming my graph. So we must know that the mother function f of x is the increasing function. And then if I'm moving to the left 2 units, so here is always 1, 0. So move the key point to the left 2 units is -1, 0. So I'm having a new graph like this. All right, that's all about the 4.2. I forgot what is this. So 4.2. If you have any question, please let me know. Okay, have a good one. Bye-bye.